Okay. Juniper, can you see my screen? Can you confirm?
Yes.
Okay, cool. So, hello everyone. My name is Siddharth. I'm a master's student at the University of Waterloo, and this is joint work with Professor Christopher Nihanyu, where we study lifespan, expectancy, and cycle size in the original autopoiesis algorithm. Now, first, we will cover some background on autopoiesis and a particular computation model which showcases it. Any entity which has a capability to organize and maintain a self over time using components it produces itself shows autopoietic organization. It was introduced by Varela, Maturana, and Uribe in 1974. They also introduced a computational model showcasing this phenomenon. Now, autopoiesis has two interesting properties: self-organization and self-maintenance. Self-organization is the phenomenon by which an entity forms, and self-maintenance is a property of the entity thus formed. Since the environment itself is changing, the entity has a process by which it maintains itself over time in the face of degeneration, and it does so using constituents it produces itself. Moreover, these processes are not explicitly programmed, but emerge out of simple rules and local interactions. An example of this in natural systems is the cell. In the original paper, the authors argue that autopoiesis is the defining property of all living systems. Now, the following describes our computation model. Now, there are elements, and these are the following elements. So one is holes, which are marker elements for empty space. We have substrate elements, which are converted to link elements for constructing the entity boundary. We have catalysts, which enable link elements to be transformed to links, and links themselves, which can be free, bonded to another link, or bonded to two links. Now, there are two kinds of rules that the elements follow. One, movement rules. Now, these are how elements move in a 2D grid, and they apply probabilistically within the neighborhood. So here the neighborhood is move neighborhood in yellow and extended neighborhood in pink. The other kind of rules are reaction rules. These are how elements interact with their moved neighbors. And all rules, including rebonding, occur within a time step. Now, this is an example run of how the system behaves once we start. And you can see entities forming and then being destroyed. Now, for the experiment, we see that the entities which are formed due to autopoietic organization, we are interested in two properties. One, how long are entities alive for before one of their links disintegrates into a substrate, that is their lifespan, and during their lifetime, how big do they get? That is their cycle size. Now we run two sets of experiments and turn the following knobs. In the first experiment, we vary the number of holes, substrate, and catalysts in the initial state of the grid, and they are placed randomly. In the second experiment, we vary the probability of disintegration. As we turn these knobs, we measure how lifespan and cycle size change in each setting. Here we see the results of our experiment. In the two box plots, the orange bars are the medians, and they give a good summary of the trends we see. On the left, we have lifespan versus grid configuration. We increase the number of holes and catalysts at the expense of substrates. Interestingly, we see that lifespan does not correlate strongly with grid configuration. Going to the right box plot, we have lifespan versus probability of disintegration. Here we increase the disintegration probability as we move right along the x-axis. In here, we see that its lifespan has a strong negative correlation with increasing the probability of disintegration. Now, to conclude, we saw results of how lifespan is affected. Cycle size is not shown here in the interest of time, but it is also affected in a similar way, though it is more robust to increase in the probability of disintegration. Our main conclusion is that given time, autopoietic entities can emerge and be sustained by following simple local rules and are not affected meaningfully by global configuration. For future work, we want to study larger parameter spaces and run for longer, that is more than 1,000 iterations, to see if our findings hold. The source code of this autopoietic system is available on GitHub. That's all I have. Thank you for listening.
Juniper, I think you're muted.
Next up, we have Emily Dolphin, and I'll be presenting her video.